Hello, Mr. Soper here, and welcome to wonderful Thursday. We are going to go ahead and dive into one of the two kinds of chemical bonding that we kind of previewed yesterday on Wednesday. So we'll take a look at what happens. By the way, I'm in my bedroom because yesterday when I made my video out in the kitchen, my wife, Mrs. Soper, was listening to me and kept laughing at some of the stupid stuff I said. So I'm in here, so she can't laugh at me anymore. If you did the warm-up, hopefully you remembered that these are the three things, or three ways, that an element can react, or can kind of do something to get that full outer shell. So option number one is it's going to give up those valence electrons. It's going to try and get rid of them. Option number two is it's going to take them from another atom that wants to get rid of them, hopefully. Option number three is it will share with another atom so that they are both happy. Okay, we're actually going to look at ionic bonding today, which is these two, the first two. So either giving up or taking. All right, so without further ado, let's take a look. All right, and if you can copy this down, feel free to pause the video if I go too fast. But we're going to ask, okay, what is an ionic bond? Okay. Ionic bonds, atoms will transfer one or more electrons to another atom to form the bond. So again, we're going to give them away or we're going to take them. When this happens, each atom is left with a complete outer shell. So if it wants to give away two, if an atom wants to give two away, then there's going to be something else that's going to take those two, and they both need to be left with a full outer shell. Now, an ionic bond forms between a metal ion and a non-metal ion. Now, what's going to happen is the metal is always going to give away its electrons. That always happens. It's going to give it away. When it does, it ends up with a positive charge. And the non-metal ion is going to take those electrons. It's going to be kind of greedy. It's going to take those electrons, ends up with a negative charge. Now, when that happens, so you've got a positively charged metal ion and you've got a negatively charged non-metal ion. Think about magnets. If you have a north and a south, those opposites attract, so they are going to then pull together. So you have two electrons, two atoms, one will give some electrons away. You'll end up with two differently or oppositely charged ions, and they're going to join together. Okay, again, feel free to pause the video if you need to write this down. Otherwise, let's go ahead and take a look at what that looks like. So for this example, I've got magnesium, and this is a Lewis dot structure. We did these a few weeks ago, but Lewis dot structure, remember we just put the chemical symbol and the valence electrons. That's it. This one is oxygen, and again, we just put the chemical symbol, and we have 6 valence electrons on this one. We have 2 on magnesium. Let's take a look at what happens. I'll get myself out of the way here. There we go. So magnesium, that is the metal, and it's going to give away the electrons to oxygen, which is the non-metal. When it does so, magnesium becomes positively charged because it's given away the negative electrons. Oxygen is going to be negatively charged because it's gained those negative electrons. And when that happens, they then join together. Right, so the chemical equation for this reaction is magnesium, and this 2+ just means that magnesium had a 2 positive charge, plus oxygen, and again we have that 2 negative charge because it gained 2 electrons, goes to MgO. How we would read this is magnesium, that's this, and oxygen yield magnesium oxide. We'll talk more about naming in a minute. That's good. Okay, so this is an ionic bond example. Yesterday in class, if you were there, I talked about how maybe you have some extra money, someone needs some money for the vending machine, you're going to give them that money, so you're going to give that away. So this is a sodium atom giving a chlorine atom its extra valence electron to make it feel happy, because everyone just wants to be happy. When it does that, gives that electron away, sodium has a third outer shell, chlorine has a third outer shell, and I like this. It says, you can have this. Wow, are you sure? Yes, I'm positive. Because he's positive. And this guy's negative. They attract. There's a really horrible love story video that I know. If I'm feeling particularly mean one day, I'll show it to you. But anyway. Let's see. This is it in kind of another form. This is the Bohr model. This is a lot more than we need when we're doing this, but just to kind of show again, this electron moving over here. Now, when sodium gets rid of that electron, it goes back to this shell. What was kind of the second to last shell now becomes this new outer shell. And again, you know the rest. When the electrons transferred over, one's positive, one's negative, and just like magnets, they attract. And again, just to kind of really emphasize it, this is what's happening. Kind of a cool animation. I'm going to skip this one for now. Well, no, I'll say this actually. Sometimes it's more than just one atom combining with one atom. Sometimes one will combine with two or three or four. That's usually the maximum we can do. But yeah, one atom will combine with a couple of ones. So we'll look at some examples of that. Just for now, know that if something has two valence electrons, it can bond with two separate atoms that only need one extra electron. Okay. If you ever feel like you need to pause this or rewind it, feel free to go ahead. Okay. Oh, this is the cheesy video, which I'm not going to play for you right now, because it's quite long. Okay, here's your assignment for today. And it requires, I'd say, a lot of attention, I guess. What I want you to do is go ahead and follow the steps. So we have 1, 2, 3. Oh, so 3 is this, 4, 5, 6. So 6 steps for each problem. So what you're going to do is, step 1, I'm going to create the Lewis dot for Na, or sodium. The way I'm going to do this is by going to a periodic table. And let me show you. If you don't have your periodic table with you, just go to ptable.com. Here's a really good one. Where am I here? There. And it's going to say, okay, step number 1, make the Lewis dot for sodium, Na. So I'm going to go to sodium, which is right here. Now, I've already put in the chemical symbol for you, so you just need to figure out how many valence electrons it has. Well, right here, it's in column 1, so it has 1 valence electron. So what you're going to do is take away these extra valence electrons, get them out of there. They don't belong, except for 1, because it just has 1 valence electron. Okay, same for chlorine. Let's go ahead and find chlorine. Remember, we're always going to bond a metal with a non-metal when we're doing ionic bonding. So if you've got a metal over this side, look over this side for chlorine. Okay, chlorine is in group 17. Remember, to find valence electrons, you take the group number. If it's above 10, subtract 10. So this one's a lot easier. I'm just going to go ahead and take 1 away. So I've got 7 left. And you'll see, this works pretty nicely. The next steps, you will write the charge for each ion. So Na, we will say, and actually let me go right back here. We'll want to take a look at our table that we made yesterday and say, okay, sodium is Na right here. What is its oxidation number or its charge? And I'll post this separately, the answer key for this. So double check this before you start the assignment. But if we look here, can't find it, there we go. If we look here, then what's going to happen is that sodium is going to lose its valence electron. And it's actually going to have a 1 positive charge. Now, when we do this, chlorine is going to get that electron, and that's going to end up 1 negative. Remember, if you gain a negative electron, you're going to end up with a 1 negative charge. Okay, step 5, write the chemical formula. And remember, that's just Na 1 plus, plus Cl 1 minus, because it's got a 1 minus charge, goes to NaCl. And then we do the compound name. Let's take a look at what this should look like. Okay, so I have gone ahead and dragged over my 1 valence electron from sodium. So that's happy now. What actually happens is it gets rid of that outer shell, and it's happy. It's given chlorine a full outer shell, so that's happy. Now, what we need to see is that this is what I kind of talked about on the last one. Write the charge for each ion. Okay, we have Na 1 plus, and we have Cl 1 minus. Step 5, just put those into an equation, and you'll say that goes to NaCl. And then you write the new compound name. This looks really fancy. It's really not. All you do is you write the non-metal first. You write the metal first. So the metal is sodium. And then you write the non-metal second. However, you just change the last part of it. Instead of saying chlorine, it says chloride. If you have something that's oxygen, it's oxide. And that's really the rules. That's, if you look through, we just have one here that's made with oxygen, one with iodine, that would be iodide. Another one with oxygen, that's oxide. And you have, 2 chlorines, that would be chloride again. This one, again, you have chlorine, you would just call it chloride. So, this one is done for you. Then you have 1, 2, 3, 4, 5 to do yourself. This may take a little while, but just go ahead, follow the steps, and let me know if you have any questions. What I will say, one last tip. It says here, use format text superscript to create the images. If you want to use this, you can copy and paste it down here. And then you can just kind of change the symbols and the numbers. That way the formatting is done for you. Again, if you have any questions, please let me know. All right, hopefully see you soon.